Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on compound interest. In the last lesson, we learned about the concepts of ratio, rate, proportion, and percentage. Today, we will learn about simple interest and compound interest. Are you ready, students? If I borrow money from a bank, I pay a percentage fee called interest. The bank lends me money because it views it as an investment. It lends the initial sum, called the principal or present value, because the amount which will be paid back is the initial sum plus the interest. This is called the future value or the accumulated value. The interest is computed on the original principal during the entire time or term of the loan at the stated annual rate of interest. Simple interest can be computed using the formula I equals P times R multiplied by T. I is the simple interest. P is the principal. R is the annual interest rate, and T is the time in years. The time period for R and T in this formula must be consistent with each other. If R is expressed as a percentage per year, then T is the number of years. Generally, a principal is borrowed at a rate of simple interest per year for a number of years. The borrower will pay back the lender an amount, A, that includes the principal plus the amount of interest. Therefore, A is equal to P plus I. This can also be expressed as P plus PRT, or P times the sum of 1 and RT. This is the formula for a future value of simple interest. The amount equals the principal multiplied by the sum of 1 and the product of the interest rate and the time period. Let us say that you have deposited 100 Birr in your bank account. At the end of the first payment period, you decide to reinvest the interest that you had earned in the account. The amount of interest you are earning will be larger than before, because both the interest and the original principal will be earning interest during the next payment period. Interest paid on interest reinvested is called compound interest. Let us see if we can find the formula for determining compound interest by using the formula for simple interest. Let us call the amount invested at the end of the first year A1. A1 is equal to the principal P times the sum of 1 and the rate R. In this case, T is equal to 1. Since the amount at the end of the first year will be the principal for the second year, A2 will be equal to A1 times the sum of 1 and R. This is the same as saying that A2 is equal to P times 1 plus R times itself, or P times 1 plus R squared. Since the amount at the end of the second year will be the principal for the third year, A3 will be equal to A2 times the sum of 1 plus R. This may be expressed as P times 1 plus R cubed. Do you see the pattern, students? Here is our formula for the year represented by N. AN equals AN minus 1 times the sum of 1 plus R. This is equal to P times 1 plus R exponent N minus 1 times 1 plus R, or P times 1 plus R exponent N. It is time for our first activity, students. Please use this formula to answer the following question. Aster deposited 5,000 Birr in a savings account that pays a 5% interest rate per year, compounded annually. Assuming that she does not deposit or withdraw any money, what will be the total amount in her account at the end of 10 years?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope that you had no trouble with this problem. Here is the formula we must use to calculate the compound interest on Aster's savings. When we substitute the correct values, we get A10 equals 5,000 times 1 plus 5% to the power of 10. Simplified, this is 5,000 times 1.05 to the power of 10. 1.05 to the power of 10 equals 1.68894. When we multiply this by 5,000, we are left with our answer, 8,144.47. Aster's total savings after 10 years would be 8,144 Birr and 47 cents. This example was a bit unusual in that interest is usually compounded more than once a year. The quoted rate of interest per year is called the annual or nominal interest rate, and the time between calculations of interest is called the conversion or compound period. Since R is the annual interest rate and the interest is compounded m times per year, the year is divided into m equals conversion periods. Therefore, we get interest expressed by R over m every 1 over m years. If interest at an annual rate per year, R, is compounded m times a year on a principal, its equation is 1 equals R over m. The future value of a compound interest is given by the formula A equals P times the sum of 1 plus R over m to the power of mt. A is the amount or future value. P is the principal. R is the annual rate. T is time in years. And m is the number of conversion periods. Try calculating compound interest for yourselves, students. 1,000 Birr is deposited at an annual interest rate of 5%. Please use this information to complete the following table.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. This is our formula. For an annual term, 1,000 times 1 plus 0.05 over 1 to the power of 1, the product is 1,050 birr. For a semi-annual term, 1,000 times 1 plus 0.05 over 2 to the power of 2, the product is 1,050 birr and 63 cents. For a quarterly term, 1,000 times 1 plus 0.05 over 4 to the power of 4, the product is 1,050 birr and 95 cents. Did you manage to complete the table? Great job. That is all for this lesson. Until next time, thank you, teacher. Thank you, students.